Hello everybody, welcome back. Alright, so another day, we are working on some new stuff. We're going to be trying to figure out how state machines work. If you're following around last time, we kind of did some videos in regards to that, but I quite frankly started falling asleep in the middle of those videos, so yeah, we didn't really make it far. Give me a second. Actually, I need to fix the title on Kick because it never fixed. After the 12, why is it listing episode 10? Hold on. Did it even say for the last time I did it too? Also my keyboard's broken again. I don't know what's going on with it. It's like cycling between working and not working. It's just the space bar. That's the only thing. I need to get a new one, but I'm kind of tight on money right now. I can never remember where the hell this is. View channel. Come on, go to, no, that's not creator dashboard. Yeah, this is it. Okay. This is it. Shit. Get that. Here. Just copy paste this. Also apologies ahead of time. I may not stop doing that. There we go. That should be better now. But yeah, I hate that. Sorry. Just keeps unmuting. We'll just close out of it. My seriously may be a bit inconsistent these next few days, even more so than it already is. Because I'm kind of pressed to make money right now until for a little while. I'm trying to find a new job right now, so kind of like in a weird situation. So if I'm not on some days, I apologize ahead of time. But yeah, so that's kind of what's going on right now. Well, I'm pulling some videos or things we were just looking at earlier. I'd love to watch this guy's like fully destructible 3D environment thing, but I don't know, the guy just goes a bit too fast, so I'm just gonna close out of these. We'll probably watch them later when I'm a bit more into what the fuck's going on. So guys, hello everybody. Sorry, let me actually give you the right thing. There we go. That's a bit better. Alright. So, where were we? Actually, we don't need to watch this. We were not even doing anything with this. I kind of wanted to watch through these because I actually really like this.
Let's create a procedural mesh for our voxel terrain using array mesh in Godot. First, we'll draw a single cube from scratch, then expand to generate the entire terrain.
Let me go back. 3. Skip hidden faces. Okay, that's what I was wondering what it said. I'm getting sidetracked already from what we were planning on doing. I want to look something up. What was it? Oh yes, I remember. Hold on a second, let me do this. Gotta open some stuff up. Give me 1 second, I'm almost done here. Where is it? So that idea for making a voxel game. Yeah, I'm probably not gonna make this first and foremost or anything, because again, this is way out of my league, or I'm like way out of my depth, trying to do something like this. But I wanted to bring this up. Yeah, this is kind of out of the blue, but I wanted to look at this. The gameplay seemed probably better for this. Is it actually showing? That's not showing anything. Oh, it is. Tear Down. So I like this game a lot. What the fuck? This was not here last time I played this. Sure, we'll play Sven. Oh, I want to look at something. The thing I was wondering is, if you like break a hole in the floor. Oh, that's weird. Oh shit. Fucking awesome. How precise can you get this? Like, I'm trying to see. Gun. Like how? Why does a hole have to be for you to fall through it? That far, okay. Where's the spray can? That's about 4x4, I'd say. The reason I'm doing any of this is I'm thinking, like, if I do make a game, I'd like the size in which you can the character should be something similar to this, or on me. That's still too kind of wide. I was thinking an 8x8. 1, 2. That's probably like a 6x6, honestly. You have to look fit through. So 8x8 isn't that far off. But this is a great game that's like does fantastic work with boxes. Mind you, however, I don't intend on going as far as fully destructible physics like this. This is like a bit crazy, you know? Look at this. Like, this is fucking insane. I shot the one part of the wall that actually had something attached to it. Yeah, look at this. I can just fucking grab this shit and move it around. I don't intend on going this far, because this is fucking insanity. But if I don't focus on physics stuff, I feel like it could potentially make the world a whole lot bigger. I mean, don't get me wrong, this is already a really big world, but you know. Something like way bigger. I'm actually curious about like what limitations I could like hit and then like go around. Like how I can circumnavigate certain limitations and stuff. I'm really interested in seeing what I'm looking for here. I'm really interested to see I'm really interested in optimization. I'm curious as to how well optimized you can make a game. Again, I barely even know how to make one to begin with, so probably not the best in the way of optimization, but little baby steps. But anyways, I was thinking about making a game. It's voxel about this resolution, perhaps, maybe a bit better. I guess we could say, because I've seen people pull off some crazy shit. What? Oh. Yeah, I see some people pull off some crazy shit with voxel games they've made. So that's something I'm very interested in learning about. Oh yeah, my keyboard is broken again. I forgot about that for a second. Trying to see what some good examples are. This one, for instance.
So I came across a video recently of this guy called John Lynn.
Let me. Yeah, this shit. Look at this. This is fucking insanity. I don't know. I don't know how you even begin to make something like this. Oh, it's just not like it's a house. And again, I don't know how big this world is. It could be really small for all I know. But even something like this. I think, if I were to guess, this is probably like an older game and not just someone's tech demo. But like this. Like, this world is fucking huge and potentially all destructible. So I'm interested in stuff like that, seeing what I'd be able to do with destructible environments. You know. But anyways. Let's see. I need to look up state machines. This is gonna fuck me up because this was not like this earlier. Use AI animations in systems at time. Let's see. Guess I'll watch this.
Hello, today I want to walk you through how to create simple but advanced state machines for your own Godot projects. We will cover how to define states within a state machine and define acceptable transitions between those states. There's a lot to cover, so subscribe to help other aspiring game developers, and now let's begin. I'm going to start off this tutorial by explaining state machines, and then we'll move into the tutorial at this timestamp if you just want to skip there. So what is a state machine? Well, basically a state machine manages the flow of logic, but it does it in a clean and more organized way than if we were just to use a ton of if, and else statements. When using a state machine, it has different set states, and it switches between those states while having one state active and all the other states as inactive. So instead of the messy if-else statements and hundreds of variables that look something like this, we can create the exact same effect by just doing this. And this is the code that we will be creating today. As you can see, it's going to make your game a lot more modular, and it's going to allow you to make more advanced states and more advanced animations for your players or enemies. So hopefully that little explanation can give you a little bit of insight into state machines, and now we can get going into the tutorial and you can actually understand what is going on as we're creating this state machine and what you can use it for in your own projects. Okay, so now that we understand what a state machine is, let's get into creating one, and we're going to end up doing this with the use of an add-on called Limbo AI, and we can actually download this add-on straight from the asset library here in our engine by going up here to the asset library and just typing in Limbo AI, and it's going to kind of organize everything for us in state machines. We still got to create everything, we still got to kind of do the work, but it's going to make everything a lot easier, and it actually makes your game run much smoother, and I really do like this. And with Limbo AI, there's a lot more features to it, like behavioral trees, which you can make in, intelligent AI, which I'm going to actually go over in the next video, where we're going to end up making an intelligent enemy, and it's going to know how to walk around, when to attack, when to do everything, right? And it's going to be really cool and super advanced as well, and it's going to be makes everything a lot simpler. And we can end up using this for state machines, and that's what we're going to be doing today. We're just going to be creating a basic player state machine, but with the use of Limbo AI. So Limbo AI, that's.
I never actually looked at the asset library before.
Click here and then click download, and then you'll have it in your.
I mean, I kind of have, but I haven't actually like explored it much. Let me pull this up.
Drag and drop. You don't have to enable anything. Even up here in the project settings, where we have plugins, you don't have to click enable like you do for most add-ons, because I don't know why that is, but for Limbo AI you don't have to, and it's already automatically enabled. As you can see up here at the top, we have a new tab, Limbo AI. We're actually not going to be making use of this.
The thing is, I don't even know what add-ons are even like worth like having or installing. Or survival game project. Ooh. Is that what I was just looking at? What the fuck? Sure, just install wherever. Yeah. Well, I actually want to look at this real quick. I also want to see like what the fucking code is behind this. Whoa, they have some sort of shader on this shit that is intense. It's blurring the fuck out of it. Look at this. This is not normal at all. That's blurring the fuck out of it. Let's see what this is. Whoa! Oh my gosh, this is so bright. On. Whoa! Hell yeah. Is everything up, or is it only terrible down? It's a bit finicky. Doesn't want to fully work sometimes. But it's interesting nonetheless. How big is this? That's pretty sizable. Oh, fuck. Regardless, this is pretty cool. What's this? In-group player. Okay. Map. This is all the code used in the map. Chunk size, preload. Chunk.tscn. Basic chunk.tscn. That's not in the scene list. Maybe it's made upon the world loading? I don't know. Generate chunk. Set chunks. Generate chunk. New. Printed triangles. Damn. They put a lot of work into this. Yeah, I was hoping we could sort by like most downloaded because I'm curious. Least recently updated. X date time. Version 1.0. Hot dog. Let's see. Oh, the application is 1.0. I thought that was saying it was from Godot version 1.0. Okay. Is this not already a thing? Let's see. What's on? Let's look up. Tools. The rendering shader. Maybe essentially bosses. Can I like launch this? I think you just launch. How did that just do? I don't know what that did. Whatever it did, it's installed now. They should just randomize each time, right? Let's see. See, fall straight in front of this one. It's just like a fucking tower. Generate it again. Is that the same one? That's the same one every time. Nothing about this map is random. What the hell? This has got some bugs in it. Don't get me wrong here, but pretty impressive overall, I'd say. Ah, yes. Oh, I want to do this. Bon voyage! Yeah, hey, I did it. The kill box is there. Oh no. That's not good. Why is it getting worse? Okay, I'm just gonna get out of there before my computer has a conniption fit. What does the player look like? Oh, they're just a sphere, I guess. Why is me looking down like make my body look weird? Like something's poking out. Oh, it's not. It's just because that's the capsule. I was saying. I thought that was like a triangle. I thought that was like my nose or something. I don't know. I had no idea what the hell that was. Oh my gosh, holding just speeds you the fuck up. Oh wait, does this like actually generate? Oh holy shit, I thought there was an edge. This is insane. This is insanity. Oh, cool. Generates in and out. That's pretty cool though. And for whatever reason, it just starts to crash once I was out of view range. Yeah, as soon as I get out of range of it, it starts freaking the fuck out. That's weird. I close this. I'm just doing shit that has nothing to do with anything.
Today because this is more of the behavioral tree type of
There's my dad again.
stuff. So if you want to create AI,
Oh, I did have something to do with something. He was using an asset library. I want to try to avoid that if I can. Well, I'm sure our asset libraries are actually really good because it helps you do a lot of dirty work. Import stuff that helps with stuff, everything. But I want to actually just understand it, not have something else do the work for me. So,
that's where you do that.
There we go. This guy.
Let's say you're designing an enemy. You want this enemy to wander
Yeah.
until it spots something, then chase that target, and if it gets close enough, give it an attack. How would you program
Bam.
this? It would be super simple to check whether there's a target and whether we're in range, then handle the different time for wandering and all the randomness. But imagine you added a few more states to that. Maybe you could see how this code would grow larger and larger. Even though this is a smaller example, I personally would use a finite state machine. First off, before we define a finite state machine, we should probably define what a state is. State is a set of conditions and a behavior to go along with it. So our wander state from before had the conditions that there was no target, and the behavior is wander randomly. And of course, our chase behavior was that we have a target and that we're not in range, and that behavior is to chase. And that's kind of how we would split things up in code. So we would have a state class, and inside of the state class, we would have a couple of methods. The first two are enter and exit, which are called when we transition to a state and leave from a state. Then we'll have two functions. Those are the update and physics update functions. The update is tied to the visual frame rate, whereas the physics is tied to the physics server. Then each state can have its own relevant information. For example, the wandering state would probably have a random direction, and maybe a speed, and maybe a time for it to wander. Then inside of the inner function, we would randomize these variables, and on update, we would tick down the timer, and if it reaches 0, we would randomize the variables again. Then inside of physics, we would probably move. And for all of the other states, it would probably be a very similar story. That's basically it for the state, and the finite state machine is simply just a collection of these states. So in our case, we would have an idle, chase, and attack state. These would all belong to one state machine. The state machine itself is responsible for handling the life cycle. So for example, if we're moving between states, it's responsible for calling the exit function on the previous state and the inner function on the new one. And it's also responsible for keeping track of what the current state is. Usually, the actual state machine is completely agnostic to what states are inside of it. It just needs to know what the current state is and what state you want to move to. So let's swap over to Godot and we'll give this a shot. So we're back in the project from before, and all I've got is this little dude. He's got a script on him that just calls move and slide, and we'll set the velocity later using the states. So the first thing I'll do is add a new state script. This will be the base script used for all other states later, so we'll set up the functions in here. We'll declare class name state and define the functions enter, exit, update, and physics update. All of these will just contain pass because we don't actually want to do anything in these functions right now. You technically could, but for our project, I'll just leave these blank. Next, I'll go ahead and add a new node to the enemy and just call this state machine. Then I'll attach a new script. So the plan is to have the state machine in the scene tree, and every state can just be a child of that node. So what I'll do is I'll define a states dictionary, and then inside of the ready function, I'll loop over all of the children. And if the child is a state, I can add it to the dictionary by using its name. And since state extends node, we can check directly here whether it's a state or not. I'll go ahead and track the current state, and then we'll go ahead and define the process and physics process functions. And inside of here, we can check if we have a current
The child.name would make okay.
state and call update and physics update respectively on the current state. But how do we move between states? Well, there's a billion different ways you could do it, but in my personal way, I would use signals. We'll head back over to the state class and add a new signal transitioned. Anytime we want to leave the state, we'll just call this signal. And inside of the state machine, anytime we register a new state, we can simply connect to the transition signal. This will connect to a function that takes in the state that called it, and the new state name that it wants to transition to. We can check if the state calling it is not the current state, and then we'll grab the new state from the state dictionary, and of course make sure that exists. Then we'll check if we have a current state. If we do, we'll call .exit, and then we'll call .enter on the new state and set the current state to the new state. One quick thing is down here I use toLower, and I will actually add that up here as well, just to make sure capitalization doesn't do anything funky. And then one last thing is I'll add an exported variable called initial state, where we can define the initial state that we want the state machine to be in. We'll check if initial state exists, and if it does, we'll call .enter, and then we'll set current state to initial state. And then next, we can start building out our separate states. The first state I'll make is just idle. I'll start by making a new script, and I'll just call this enemy idle. Instead of extending node, we'll instead extend state, and set the class name to enemy idle. And inside of this state, we'll have the two randomized variables, which are move direction and wander time, and then a function to randomize those variables. And then when we enter the state, we'll just call that random function. And then the update function should be really simple. We'll just check if wander time is greater than 0. If it is, we'll tick down using delta, and then otherwise, we'll just randomize these variables again. And then for the physics update, we'll actually add two more variables. These are a reference to the enemy that we're going to be updating and the move speed that we want to update to. Then in the physics update, we'll check if enemy exists, and if it does, we'll just set the velocity to direction times speed. And then of course, we probably want to test this to make sure this works before we go any further. So I'll go over to the state machine and add a new node. If we search enemy idle, we should see this here, and I'll assign the enemy, and then I'll assign the initial state. Then if I go in game, it looks a little jank, but he's definitely moving around. And just for visuals, back in the enemy, I've added it so that if we're moving, we're going to play the run animation and flip the sprite based on which way we're going. And that already looks a lot better. I'll go ahead and rename this to just idle, and we'll do one more state together. So back down in states, I'll add a new script, and this one will be enemy follow. And just like before, we'll extend state and set up the class name. And we of course need to know what we're following. For this example, I'll just assume we're following the player, and I'll add the player to its own group. Then I'll add a player as a target, and inside of the inner function, I'll just grab the player from the group. And for the physics update, just like before, I'll add in a reference to the enemy and the move speed. And then inside of the function, we'll get the direction between the player and the enemy. And if it's outside of some distance, we'll move the enemy towards the player. Otherwise, we'll have it stand still. And of course, we want to test this one too. So I'll add it as a child. I'll assign the enemy and set the initial state to the follow state. And I'll also rename it to just follow. Then if I go in game, he follows. So the last thing to do is moving between states. This is very much state dependent, and I think it's a lot easier if I do it for the follow state first. So for the follow state, we want it to go back to being idle once we've reached a certain threshold. So I'll say if the distance is greater than 50, we'll call transition.emit. Note that we're passing in the current state and the name of the new state that we want to go to. And if we give this a shot in game, we can see that he stops following us after a certain distance. And back in idle, we can do the exact same thing. Of course, we'll need a reference to the player, so we can grab that from the tree. And inside of physics update, we can grab the direction between the player and the enemy, and if it's within some threshold, we can then transition to the follow state. And if we give that a shot in game, you can see he swaps to idle, and if we get close, he starts to follow again.
One second. I'm about to mute myself. Hold on. Alright, cough. Oh shit, I haven't been showing my screen this whole time. Fuck. I'm sorry about that. Damn. When did it go dark at? Did I even show you the whole thing I was doing with teardown? Fuck, man. Oh yeah, teardown showed up, but then after that, I forgot to turn it back. Damn! I'm so sorry. Well, that sucked. I just realized that you guys haven't been seeing anything for the past, what, half hour? Ah, fuck. I'm sorry about that. Well, you didn't miss much. I was just fiddling around with the asset library I found in the Godot engine. So, I was just fucking with that. I've been watching this guy's video. Oh, something I do need to show that I was looking at. I was looking at this earlier. Sorry if I'm just reshowing you something I actually did see.
Main advantages of using
I was talking about this when I was saying, look at
is
this crazy
procedural
shit.
generation and destructibility.
fossils.
However, they kind of suck in graphic resolution and performance. So if you're gonna sacrifice these to make a voxel-based game, it should probably have like terrain molding, adding and removing chunks as a central part of the gameplay. Minecraft is often described as one such game, but even though it stores the map as a voxel grid, the game is in fact rendered using polygons. The only notable voxel-based game in recent memory is Teardown, which you probably heard
There we
of.
go.
It's kind of
Oh,
popping on
sorry
YouTube
about
right
that.
now. You can probably guess what type of game it is based on the title, but even though destroy everything sounds great, I'm more interested in destroy everything but it's pretty and colorful, aka John Lynn's game. Yes, this is in fact not only a tech demo, but an actual game that he's working on alongside the engine that he's developing. It hasn't been officially revealed yet, but he does refer to it as something that we'll eventually get to play. Now, I'm not gonna pretend to
That was 4 years ago. Dude. His last post was 4 years ago. What, oh, does anyone say anything about it? I lost hope. We're so... Yeah, like a Twitter? He has a Twitter. You can check his Twitter. Where's you? This shit. Well, that's what he's been doing, I guess. Fucking crazy. Absolute insanity. Damn, I wish we'd get some updates on this. 'Cause I thought there'd be a lot more about it and stuff. But yeah. We were literally just looking at this. Oh shit, there you go. Dude, this is what I'm talking about here. Like, this would be so fucking cool. That's like a voxel game. Again, I have no idea how I managed to pull this shit off. Like, it being this fine... Excuse me. Fine grain, I guess? Like, it's so, like, detailed, even though they're, like, voxels. So I'm like, how the hell is he doing that? Like, genuinely. That's insanity. Well, look at that shit. Right? Like, how the fuck? That's fucking crazy. Also begs the question, how big is this? Like, how far down does this go? Like, what's the size of the map? That's things I'm wondering about. Also, are these interactable or is this just procedurally generated? Because even if they're not interactable and just like decorative, that's still fucking impressive. Very fucking impressive. This thing used 3 gigabytes of VRAM and ran 10 times faster at the low resolution. Simulation faster. Well, there you go. There's the size of the place. The stars and its attempt at increasing the view distance. Requested she not only that, but rewrite a brand new book. Run up to 8 times 512 cubic detail. Increase with animation support, high compression rate, and per voxel material attributes. How the fuck does he even do this? Voxel ray tracing. What the
Hi,
fuck?
this is my dog, and his name is Voxel. And as you noticed, today we are
This
gonna
sick
talk
ass dog,
about
dude.
rendering voxels. I mean, many voxels. These voxels. And we will learn how to do that using ray tracing. I'm sure everyone has played Minecraft, or at least seen its gameplay, and it's the first game that comes to mind when speaking about voxels. Entire Minecraft world is made of voxels, cubes the size of roughly 1 meter. But these voxels are kind of big, right? And there is definitely no ray tracing in Minecraft, except maybe in shaders. So, this is where modern voxels games come into play, such as Teardown. This game has a voxel size of just 10 centimeters. It's 1000 times more voxels per same volume than in Minecraft. But how do they do that? Minecraft with its relatively simple graphics is sometimes running slow even on good hardware, and in Teardown we see such detailed worlds with much more interesting lighting and effects. There's definitely some magic involved. And the name of this magic is ray tracing. In old times, to render voxels, people were usually transforming volumetric voxel data into triangle meshes and rendering them using rasterization.
Yeah.
And it worked great, because GPUs are created to render triangles fast. But then people started to push voxel sizes lower and lower to achieve more fidelity in their games. And here lies the problem. It turns out that if you are scaling down your voxel by a factor of 10, you need hundreds or even
Like, what
1000
the
times
fuck,
more
dude?
triangles to represent the mesh. That's a lot of processing power. But let's look at the number of pixels on the screen. It is constant. No matter what resolution voxels have, the number of pixels on the screen stays the same. And here comes the ray tracing. Instead of rendering 1000 times more triangles, we can just shoot rays from each pixel whose number stays the same, and that's it. But in order to make this work, we need to find a way to trace rays fast. Real fast. How can we do that? To solve this problem, let's look at what voxel data represents. In the simplest case, voxel can have two states. empty or filled. Then, since this is some sort of volumetric data, the ray marching naturally comes to mind. Ray marching is a technique of tracing rays by advancing the point along the ray by some safe distance until we hit something. And in fact, it's quite easy to do a ray marching on voxel data. Check if the voxel on the current position is filled or not. If it's filled, we have a hit. If it's empty, just step to the next voxel and repeat the process. Sounds easy, right? But the devil is in the details. It turns out that answering which voxel is next is not very trivial. Simplest approach that we can come up with, fixed step. We can just advance point forward with the constant step length. But it's easy to show that for any reasonable step size, we will be missing some corners of the voxels, which will result in unpleasant artifacts.
That's what I was thinking. Eventually gonna miss something.
But there is an algorithm that solves this problem. For any combination of ray and direction, it can find the next point where the ray will intersect the voxel grid.
There goes my lights again.
This by finding the time of intersection of the ray with each of three axes, and selecting a minimal step that will bring the point to some integer coordinate along some axis. A link to this paper you can find in the description.
Hell yeah.
So, are we done now? Not quite. It was just one ray per pixel, but you would definitely want some rays for shadows, for ambient occlusion, for reflections, and so on, and this huge number of rays per pixels will degrade the performance very quickly. That is why we need some kind of optimization. There are a lot of ways to optimize ray marching on voxel grid. One approach is to build a tree that in each node has 8 child nodes, and if all of the child nodes are empty, we can consider the parent node empty as well, and just skip it during the ray marching by making larger steps. This can boost the performance dramatically, because in some cases where rays needed to travel through hundreds of voxels, now we can make maybe just a few steps and find the hit. Another approach is to use an idea similar to signed distance field. In each voxel we can store some additional data, the distance to the nearest non-empty voxel. This will result in similar boost for the performance, but it's a bit harder to maintain this distance field up to date. That's not the end of all optimization techniques. There is a way to use fixed step ray marching without visible
It's so weird listening to these things, because like naturally in your head you're thinking to yourself, okay, adding this is gonna make it run slower, because it's like calculating extra stuff, but it somehow is just making it faster. And my brain's like, how the fuck is this faster?
And the full
You know?
optimization techniques. There is a way to use fixed step ray marching without visible artifacts. There is cone tracing, there is level of details optimization, and many others. But unfortunately, that's beyond the scope of this video. So that's it for today. Thank you for watching, subscribe, leave a comment, and
Nice.
see you soon!
Same guy, different guy.
Today we're reinventing voxel ray traversal from scratch to be able to render over 32 billion voxels in real time. Most voxel games, like Minecraft, convert their worlds into triangle meshes to
This
render
is
them.
what I was originally
To me-
thinking of doing. It's just triangle meshes?
To me, this has always felt like a compromise. We waste time, memory, and complexity converting perfectly good voxel data into triangles because GPUs are optimized for triangle rasterization. But what if we could render the world directly? No triangles, no meshing, and somehow do it fast enough for real time. That's exactly what we'll do today. We'll go from the basics of what a voxel even is to an algorithm capable of rendering billions of voxels in real time by casting a ray for each pixel on the screen using the GPU. And towards the end, I'll show you one
Yeah,
simple
what you're talking
optimization
about.
technique that 10x'd the FPS. So, how do we go from a bunch of voxels and a camera to pixels on a screen? Well, to answer that, we need to start at the very beginning. What is a voxel? The screen you're watching this video on is made up of millions of physical pixels, behind each of which is a logical pixel, a simple piece of data that determines its color. This is often an RGB color, but it doesn't have to be. It could just as well be a single luminance value, or literally anything else, and it would still be a pixel. In my opinion, the only thing required for something to be a pixel is that it's a small building block of 2D space. In the same way, we can imagine 3D space as being made up of so-called voxels. For simplicity, my voxels will each be a single bit of data. On or off, 1 or 0, true or false, solid or empty. But like pixels, voxels can store any kind of data you want. For example, each voxel could hold an integer representing a material type like air, stone, grass, dirt, etc., etc. But the idea of a grid of voxels itself doesn't help us a lot unless we can efficiently read and write it to memory. Therefore, we'll use this flattening function to convert a 3D coordinate to a 1D index, allowing us to store the voxel data in an array of size width times depth times height. You can think of this function as taking each layer along the y-axis and placing them side by side along the x-axis, and then taking each row along the z-axis and placing them end to end. There are other methods that preserve spatial locality better to improve memory performance, or ones that compress the voxel data to use less memory overall, but I'll talk more about those towards the end of the video. Going forward, the visualizations will be in 2D, and the math and algorithms will be in 3D, but all of it works in any dimension you want, with only a few minor modifications. Finally, we need to be able to convert an arbitrary position in space to the corresponding voxel coordinate, and for that, we'll just take the floor of each component. If this position has the possibility of being outside of the grid, due to numerical errors or actually being outside, we'll have to clamp it or check it to make sure we don't access out of bounds. Now that we know what a voxel is, how do we describe the idea of a pixel looking at one? That's where the mathematical concept of a ray comes in, which leads us to the next question. What is a ray? In our case, it will make the most sense to define a ray given by the origin O and the non-zero direction D as the set of all points P that satisfy these two constraints. In other words, all points from the given origin along the given direction. The variable t is a parameter that tells us how many multiples of the direction we've moved from the origin. Note that nowhere in this definition do we say that the direction is normalized. It can be whatever length you want, as long as it's not 0. So, given an array corresponding to some pixel, we need to figure out if it hits a voxel, and if so, which one. The idea is to walk through the voxel grid in increasing values of t until we either find the first solid one or exit the bounds of the grid. This is what's known as voxel ray traversal. Now that we know the idea behind what voxel ray traversal is, we can start to think about how we would implement it. Let's begin with the naive method, because every good computer science problem starts with something painfully slow and completely wrong.
Like me.
In this case, that would be to just start at the ray origin, stepping forward in small delta t multiples of the direction, checking for a solid voxel at each step. This works, but it has one major issue. It can completely miss voxels which the ray should intersect with. And if we try to minimize the risk of this by decreasing the step size, we could spend hundreds or thousands of iterations on a single voxel, which is very slow, not to mention that it doesn't even fix the issue. So let's take a step back and think about the problem again. We have a grid and a ray, and we want to determine which voxels the ray intersects with in order. So let's start simple. How do we find the first voxel? If the origin is inside of the grid, we know that the first voxel is just the floor of the ray origin. But if it's outside, we somehow need to calculate where the ray enters the axis-aligned bounding box around the grid. For this, we'll need a Ray AABB intersection algorithm. To do this,
Alright.
we will take the mathematical definition of a ray and the mathematical definition of an AABB and solve for the ray parameter t. After working through the math and handling some edge cases, we arrive at this algorithm, known as the slab method for ray AABB intersection. Now, because it's almost always faster to multiply than to divide, it makes sense to pre-compute 1 over the direction and store that in our ray struct, and then multiply by that instead of divide by the direction. From the ray AABB intersection algorithm, we get the values of t when the ray enters and exits the bounding box. If we don't hit the bounding box, we know that we won't hit a single voxel in the grid either, so we can return early. Otherwise, we use the first t value with the ray definition to calculate the point of entry. Since this point has the chance of being slightly outside of the grid due to floating point errors, we'll need to use the clamping version when we get the corresponding voxel coordinate. Now that we know how to get the first voxel that the ray intersects with, the only thing we need for a complete voxel ray traversal algorithm is a way to get the next voxel, since then we can just do that in a loop until we hit a solid voxel or go out of bounds. So, given a ray, which we know intersects with a given voxel, how do we find the next voxel that the ray intersects with? Well, we can imagine the voxel grid as being made up of a stack of axis-aligned planes along each axis. The ray travels through these planes, and whenever it crosses one of them, we enter a new voxel. So to find the next voxel, all we need to do is figure out which of these planes the ray will exit the voxel through. The lesser plane on each axis just has the positions of the components of v, and the greater planes the components of v plus 1. First of all, we can notice that if the x component of the direction is positive, we can never exit through the lesser x-plane, and if it's negative, we can never exit through the greater x-plane. This applies to y and z too, which brings us down to 1 plane per axis, which we can determine the positions of based on the sign of the direction. Because of some quirks of floating point 0, we'll actually want to use the sign of the inverse of the direction instead of the sign of the direction directly. Now that we know the position of the planes, we just need to calculate which plane the ray intersects with first. So let's focus on the x-plane. Since the x-plane is defined as all points for which the x-coordinate is a certain value, let's call it x0, and the ray is defined as all points that satisfy this equation, we just have to solve for the value of t when the x-component of p is equal to x0. This is just a linear equation, and by solving it, we get this. And I'll call it tx because it's the t value to hit the x-plane. Of course, we could just as well have done this for the y-axis or the z-axis, and the derivation would have been the same. Now that we have the 3 t values, we just have to compare them to see which one occurs first. From the sign of the direction, we also know if we're supposed to step in the positive or negative direction. In other words, to get the next voxel in the traversal, we want to add the sign of the direction to the component of the voxel coordinate for which the plane intersection t value is lowest. And again, for the same reason, we'll use the sign of the inverse instead. Putting it all together, we first calculate the initial voxel using the ray AABB intersection algorithm. Then, we repeatedly step to the next voxel by comparing the t values for the plane intersections. And if we continue this process until we hit a solid voxel or exit the bounds of the grid, we will have traversed every intersected voxel. One quick improvement. We can see that each iteration chord is increased by the sign of the direction, which means that t is increased by the sign of direction times the inverse of direction, in other words, the absolute value of the inverse of the direction. Therefore, we can pull out the entirety of t and increment it each iteration instead. The algorithm that we now have is essentially the one described by Amanatides and Wu in their 1987 paper, A Fast Voxel Traversal Algorithm for Ray Tracing.
Fucking 1987?
Now
Are you kidding me? Holy shit.
Algorithm for ray tracing.
30 DDA. Version of DDA, which is not there. Also a ridge partial.
Now let's use this algorithm to render something. And for that, we of course need something to render. Therefore, I have chosen the Stanford Bunny, a model which is very popular in computer graphics. The Stanford Bunny is a triangle mesh, so we'll need to voxelize it, which I won't cover how to do in this video, but the algorithm is included in the GitHub repository in the description below, along with a bare-bones implementation of this video's topic in Rust and Vulkan. And now, if we set up a camera and shoot a ray for each pixel using a compute shader running the algorithm, we get this. Right now, the traversal only tells us if we miss or which voxel we hit. But with a bit of extra math, we can efficiently calculate which face of the voxel we hit, where on the face we hit, and how far from the camera it happened. This gives us everything we need for basic shading and texturing, or even launching secondary rays for ray tracing. Now it's time for that one optimization that I alluded to at the start of the video. Currently, at a grid resolution of 2048 cubed and a screen resolution of 1000 by 1000, we're getting about 12 FPS. After this optimization, we'll hit roughly 121 FPS, which is a 10x speedup. But before we get to that, I want to cover an alternative optimization which is almost as good, but way easier to explain. In the What is a Voxel section of this video, we covered the flattening function, and I mentioned that there are other ways of doing it. It turns out that if we switch to this one, known as a z-order curve, we get 102 FPS, which is already over 8 times faster. You might be thinking, wait, we just made the flattening function way more complicated, and it got faster?
My thoughts fucking exactly, dude. Holy shit.
Yeah. The reason why is that with a z-order curve, we place voxels that are nearby in space, nearby in memory. This has two main implications on the GPU. First of all, since our voxel ray traversal always steps from one voxel to a neighboring one, this improves the likelihood that the next voxel is already in the cache. And second of all, it improves the likelihood that two nearby rays want to access the same memory, meaning that the GPU doesn't have to read as much data into cache. All in all, this means we spend less time waiting for memory to read, and more time actually traversing. Now, like I said before, there's actually a better way to do this. Since we're doing the traversal on the GPU, we have access to GPU-specific structures like 3D textures, which are heavily optimized for data locality using way more sophisticated methods than just z-order curves. Switching to storing our voxels in a 3D image brings us to 121 FPS, which is a 10 times improvement over the original 12. So by rethinking how the voxel data is stored in memory, first with a z-order curve and then a 3D texture, we brought our FPS from 12 to 121 without even changing the algorithm itself. So there you have it. From the definitions of voxels, rays, and traversals to a complete real-time rendering pipeline with 0 triangles, capable of rendering billions of voxels. Of course, this is nowhere close to an end-all be-all. There are huge improvement possibilities to both the data structure and the algorithm. For example, what if we could compress the data so that more voxels can fit in less memory? Or what if we knew that larger regions of the grid were completely empty, meaning that we could step through them in their entirety all in one single iteration? But I'll leave that for the next video, where I'll be covering sparse voxel octrees and an improved voxel ray traversal algorithm that takes advantage of the sparseness. Thank you for watching, and until next time, goodbye.
Fuck, dude, this would make such like a great engine, just using stuff like this. Oh, I'd probably have to write my own custom engine in order to get something like this to work. Well, who knows? You could probably do it in Godot if you knew what you were doing. You don't. Where is it that I showed the paper?
For ray tracing.
It was called voxel ray traversal. Alright. Well, damn. Yeah, I'm sure this is probably what this guy's using. Actually, I could look this up, probably. Yeah, well. That's the traversal there. Is using procedural geometry with ray tracing acceleration structures plus intersection shaders. No idea what the fuck any of that means. But one of these days I'm sure we'll find out. Yeah,
Now
we
let's
were
use
gonna do
this
state
algorithm.
machines. That's right. Okay, so let's just do new one, state machines. Test. Browse. F. Godot projects. Select current folder. Great. So I could just make a so let's just say I do this. Say that's the character. This is the enemy. Go bam. Bam, wait, no, wait. Visibility, there you go. Modulate. Modulate them to be fucking red. Wow, enemy, oh, scary. Oh, he's gonna, get you. Okay. Whatever.
That's the absolute basics of a state machine, but there are a lot of things you could clean up about this. For example, you notice how both of these states have access to the enemy, but instead of having access to the enemy directly, there could be an intermediate state object that these states modify, and the enemy just grabs every frame. Or since you notice that these three variables are duplicated between idle and follow, you could extract them to an enemy state class and have all of the enemy states extend from that.
Hold on. Using base classes. Default, which is recommended for non-node objects. Okay. Using .new. Let's ask the funny bot that everyone loves. What does the new it's not a function, it's a method, I think. New instance of a class. Maybe let's say class was the INIT. Yeah, it does not automatically add to the scene tree. So instead use instantiate. Summary from a script slash class. When my spacebar is working again. What the fuck? Would you use new if doesn't get added? Use new when you want to create an object in memory, but not necessarily want to exist in the scene tree yet or ever. Objects are not nodes, so they can't scene tree anyway. Examples: timer, node. The timer's not a node. Oh, if not add as a node. Resource HTTP request. Okay. Add idle. For a inventory dot new. Add item stored. Okay. So and so it creates a new, okay, so like I could use this to like add a new object into an array, basically, and other stuff as well. Okay. Variable bolus new. You go to bullet position, add child bullet. You need something briefly. You just need something briefly. Variable for okay. You dot new. Enemy. Okay. Scripts slash classes for scenes. Okay. put it in the world. Okay. You want to tell me? No, not trying to do anything like that. I'm just trying to figure this out. These state machines. Where objects can only be with all attack hurt. Well, let me ask them this. I'm sure on like a smaller scale of the projects we're working on, this doesn't really matter, but I need to ask this question just because out of curiosity. Because means multiple nodes does it runs slower? Or answer no, not in any meaningful way. Oh damn, okay. But in that case, alright, that's okay. So that's what I was curious about. I knew it probably like didn't like affect it in any meaningful way, but I just wanted to be sure. Because in my head, that's like, okay, so more than one node, it's probably gonna run a little slower than just one node. Which technically, yes. But that's not unless you're like having like tens of thousands of nodes. Because again, I'm not super familiar with like how quickly these sort of things run certain stuff. Because in my brain, nodes are like kind of intensive. Our object orient is like four. Caveat. Okay, yeah, that's yeah, I remember I looked this up earlier. Well, it doesn't remember that conversation, but I think I did that on my phone, but I was wondering about this. Good. Also games and most. I had to ask would the box okay. So okay. because I don't know, like, when it comes to stuff like this, like, I don't know, like, what level you need to be on in order to, like, perform these sort of things. Like, because, like, low level means, like, you have, like, from the ground up, like, stuff, right? You know what I'm talking about? 'Cause I don't know, I think it does a low level engine. Rather than a high level one. What I'm saying is, like, it's like Linux versus Windows, right? Linux is like a much lower level system than Windows is. Windows is like higher level in the way of like what you're able to access, pretty much. Because Windows, you're not able to access nearly as many stuff as if you were to, like, have your own Linux computer, right? So that's why Linux is, I believe, considered low level, because you have, like, ground up, like, more ability to access certain stuff. So in my head, voxel ray traversal is more of a low level sort of thing, just because of how, like, complex, because it's like you literally use the pixels on your screen or to ray trace, or yeah, probably not like your actual monitor itself, probably like just the in-game pixels. But you get what I'm saying, I think, right? Why not? I probably sound like a psychopath, but I'm probably just sputtering nonsense. But it's just math. Okay. Reasonable use. Plus, if needed, can handle thousands completely. Special patch tracing. Used for block selection. Feel for huge worlds. It depends on what you mean by ray trace. GPU or CPU? Cool. Pixel. Yeah, I'm not reading all this. I'm not gonna do any of this stuff. I just want to see lighting. Not. Forest trees. The fuck is that? Hold on. The tree structure to efficiently represent affiliated environments. Well, hot damn. If these is like, I'm trying to like actually zoom in on this. Because this is actually made of voxels. This is pretty impressive, I think. And not opening Reddit any more than that. So voxel engine, chunks with meshes, GPU, shader base. Oh, let me state machine examples. Fine, we're going back. Oh wait, I should probably preface Godot. Ow! Fuck. Right, you know what? Fuck it, we're going back to this. So bright. I thought I turned fucking the dark mode on. Oh yeah, we turned it back off, didn't we? I don't remember why we did that. Hold on. Hey, there we go. Can't remember where it was. Okay. Excuse me. Fuck, I looked this up before, but I need a refresher. What are enums? Generation. Now. What is a way to define a group name of named constant values? So random numbers like oh, I could have used that because I remember actually saying fuck it, we'll save this. We'll continue this later. Sure. I just fucking let's just get out of this. We'll yeah, don't save. Fuck it. This one. Because we were doing using 0 and 1 to detect left and right on this. So if I go in here, where is it? Yeah, look, we're using 1 for left and -1 for right. Mission tracker. Alright, I didn't even know what the hell I was doing with half of this stuff. I would say I'm impressed with my ability to have done like a lot of this stuff. Just from what little I did know. Because I mean, like, overall I'd say that this is pretty impressive, even though looks like dog shit. This is like, well, I mean, not visually. I'm saying like if you look at the code back here, that's. If you look at the code back here, like this is a lot of shit. This is just vomit on the screen, like way too much stuff. Like I need to like simplify, like make this stuff like look way better. But I'll be honest with you. All things considered, I think I did a damn good job with what resources I was given. Broke the simulation. I'm getting out of here. Okay. Anyways, from what little I did know, you know, I'm glad I managed to do what I did. Again, the code of this is incredibly bad. Written. Like, I should be ashamed, but I'm just not, because you know what? Y'all gotta start somewhere. And hell, I actually still like those sprites and stuff. I think I did a good job with those. The left and right ones, I still did actually add like an actual walking thing. Probably, again, this is just like a test thing. Not like I'm actually selling this. But for the most part, I might turn this into like a fully fledged like game or something at some point, but for the most part, I did a pretty good job given what I did know. But again, it could be infinitely better. Anyways, back to this. Items are useful. Deal with things like these directions, game modes. They're prone. Let's see. What does enumeration mean? The act of enumerating. Thank you so much. I'm so fucking happy you said that to me. Oh my gosh. Okay. To count off or name one by one list. Especially in games. Thank you. I was wondering where it started. I was thinking it was 0, but part of me was thinking, wondering if it started at -1. I don't really remember why I was thinking that, but you know. Difference between enum and array. I think I already know because enum is constants, arrays are not. Yep. Used for fixed categories. Items. What's the name of data? So basically, yeah. Becomes idle equals 0. Run. Append. Okay, so yeah. There's that mess up again. that basically the same thing? No states. Don't change. Okay, so I guess that's what it means by not really. Which one? Oh, let me fucking crank up the music. Let me pump up the jams for you. Oh, okay. I'm seeing this now. Yeah, I get it now. Kinda, sorta.
But regardless of that, I hope this is a good look at how I and the enemy just grabbed.
Well, let me look at the entering exit states of these.
Then transition to the follow state, and if we give that a shot in game, and if it can grab that from the tree, and inside of physics update, we can grab the direction between the player and the enemy, and if it's within some threshold. And we wanted to go back to being idle and close to the we want out and I'll just here and I'll add a new I'll go ahead and rename this to just idle, and we'll do one more state together. So back down looks a lot better. I'll go ahead and rename this to just idle, and we'll do one more state together. So back down in states, I'll add a new script, and this one will be enemy follow. And just like before, we'll extend state and set up the class name, and we of course need to know what we're following. For this example, I'll just assume we're following the player, and I'll add the player to its own group. Then I'll add a player as a target, and inside of the inner function, I'll just grab the player from the group. And for the physics update, just like before, I'll add in a reference to the enemy and the move speed, and then inside of the function, we'll get the direction between the player and the enemy, and if it's outside of some distance, we'll move the enemy towards the player. Otherwise, we'll have it stand still. And of course, we want to test this one too, so I'll add it as a child. I'll assign
Hell yeah. Oh hell yeah. Ow, my fucking eyes. Here's the sprite creator, so go ahead and thank him for all his hard work. I did not know I was gonna get flashbanged again. Oh wait, where is the... I saw the download. Oh, there he is. PC. I was curious if it had the Creative Commons license. Hold on. Just want to look at this. Let's see it. New folder. Go. This up. There. Epic. Extract here. Oh, I guess I didn't. Need to go that far then. Hold on a minute. There we go. What is this connect? It's here. Oh, credit is required. Okay. Okay. Reading. Itself or resell on other platforms. Your project. Making your project open source is also allowed. Hell yeah. A notice space. Oh, the licensing terms. NFTs, AI training is not allowed. Creative enough. No sprites in the same style or using. Also allowed. Sick. I was just wondering like what his like thing was. I'd say that's pretty fair, pretty reasonable. Like that. Got chickens. Hell yeah. Blurry as hell. Let's go. This image finder, viewfinder does not like look at that. Oh dude, he's chopping down shit. We make a game where he's like an absolute like maniac and he kills people with that. That's what we need to do. Kill sprites. Okay, cool. I'm glad he added those as their own like sprite sheet. Objects. This is pretty good. You can't really see it in the resolution I want it. These are actually pixelated, but it's just Windows like images fucking sucks when it comes to looking at pixel art. But this is pretty cool. I like this. Need wooden bridge for your projects. There you go. Simple milk and grass item. Hell yeah. If you ever need it for your simple milk and grassing needs, there you go. We have 2 egg items. We got egg item and egg underscore item. Flash, you get fucking jump scared by an egg jump scare. Yeah. Don't know why there's 2 of them, but there you go. They're here now, here to stay. Yeah. I actually like this. I'd probably use this to prototype some stuff. Fuck around with it, so I'm gonna keep that in there. Anyways, check him out. He makes cool shit, it looks like. So what's his fucking name? Hold on. Yeah, get off my screen. I don't want it. Leave me alone. Cup Nooble. Beautiful name. Ah, still in development. Roadmap for 2024. I think we're slightly past that at this point, to be honest with you. Can I... What else has he made, actually? Oh, hell yeah. I had a UI pack, an asset... Well, I think we will just look at the asset pack. Dude, this UI pack's fucking sick. Thanks for your patience. You're busy. Sorry, pack. Hell yeah. What was this posted? Ah, Cozy Little Winter Sprites, 58 days ago. Fuck yeah. Let me look at this immediately. Hell yeah. Look at that hat on that snowman. That's amazing. Can you tell I have ADHD? I mean, because I try it fucking constantly. Doing everything other than like the thing we set out to do today. See, I want to set up state machines. I feel like we need to like figure out how class names work first. So how to use class. Why sometimes happens, I don't know. What is this? Let's do governance. Let's do node. Do my class dot new. What is this? I'll send you the script. Chat. You too. Yeah, it's just back all of a sudden. I don't know what's causing that. I know. Or if it's turns to your conversation or study session helps practice, review, and memorize concepts. Spaced repetition or interactive exercise. Study on a message. Quiz you on material, summarize key points. Alright. Yeah, that's pretty cool. I'll try this. GD script. Yes. Okay. Oh, shit, he knows. Jeez. Variable can change. Constant cannot. This cannot change. I have. I mean, what context? I'm just gonna say A. What? Did we just change it to 20? This is correct because score is a variable and oh, I was supposed to say A and C. I was thinking it was saying like just like changing this. I mean, I guess yeah. I know A and C were both right. Shut up. I thought I could only choose one. So I was like, I mean, that's the most correct, I guess. That was 100, and I called damage 30. What printed? 70. Hold on. Let me start a new chat. Study. Me understand this script. Fucking damn it. I have little experience focusing mind general thing odds So that'd be sure. See, that's not doing it. What the fuck? Bring boolean. Yeah. Equal to 70. Marine health drops below 50. Actually, it'll be warning low health. It'd be together as one thing. Is now 40. What? Oh fuck yeah, that's right. No. Yeah, I could use this to actually study some shit. This isn't bad. I'll look into this more. This is the one thing I like using that part. I like actually using it to like rip code and like put it in my stuff. I don't like vibe coding at all. I used it that one time to see if it could actually make that button do the thing I wanted it to do, or if I was even close to doing it the right way. But other than that, I wasn't. Well, I kind of was, but I was using stuff I didn't even know about, like, that I didn't even know existed, which was the what was it? The tweening. The tweening thing with the button. Oh man. Sorry, I'm trying to. I got shut up my camera. It's like whenever it's dark, for whatever reason, the frame rate dips. I don't know why. I don't know what's causes it, but the frame rate just goes down whenever my lighting goes down. Like if that light were on, the one that's like what am I playing with over there, like my ceiling light, if that was on, my frame rate would be higher. But it's lower right now. You'd like just barely tell. You can probably see when it cuts out. You can probably see the frame rate drop noticeably. But anyways, yeah, I think I'll fuck around with this a bit more. I like using it as a learning or teaching tool because it's really good at that. It's really good at compiling information and like helping you figure stuff out. I mean, I already know this shit. I already know the stuff it's telling me right now, but like if I asked it like more so to get into like state machines like I was saying earlier and stuff, then I feel like it would be like a much I feel like it'd be better way of just me learning this stuff instead of hoping to find a good tutorial that works for me. I feel like people hate on this stuff a bit too much. I get the hate. People use it just generally in the wrong way, like a lot of times. They're just like, hey, give me an answer, you know, which, I mean, that's what it's there for. That's what it exists, is to give you answers to things. But like using it in this way, I feel is a lot more reasonable than saying, hey, give me a program that can do X thing, you know? I feel like it kind of takes things out of stuff a bit. You know, like that. It takes the human element out of fucking programming. Which I think in general is not good. Because, I mean, sure there's human error, but still, but there's also AI error. Sometimes it just outright fucks things up. Especially when you get like the longer like lines of code and stuff. If it's still like much smaller stuff, usually it does pretty good. Like 99 out of 100, I'd say it does good. But once you start getting like longer and longer with stuff, it starts to break down a bit. Like let's say it's probably like 9 out of 10, which is just hell, even when it fucks up like that 1 out of 100 times, that's completely unacceptable for when you're like working on like major projects and stuff. Plus, if you actually have a human like actually behind it, operating it, like typing stuff out, figuring things out and stuff, sure, it's probably slower, but at least they'll like test it and be like, oh, this doesn't actually work. Like you'll get thrown an error. Instead of like you asking like an AI to be like, hey, give me this, copy, paste into the thing. It's not working. I don't know why it's not working. You know? Like it's a whole thing. But just general like using it as like a teaching tool, I think this is a good way of using it. So anyways, I'll see what I can figure out. I hate that I didn't really do that with just state machines today. Like literally the episode name is State Machine. I haven't done shit. I looked at a couple videos about it and that was it. Well, I looked at one video and that was it. I got sidetracked like 12 times. Get ready to get flashbang. Look out. Ready, 3, 2, 1, click. Yeah. I warned you. Warned you ahead of time. I'll press for. Okay. This is just all text. That you gotta do it, which is still good. But still, nodes. This give you a good. Overall, this GD Quest guy, he's really good at stuff. I wish a lot of his courses weren't paid for, but he has so many like free stuff that I'd say it like balances out. I've never been one to really buy courses for anything, because I mean, like, what if it just doesn't click? Then I just out of money, you know, that sort of thing. So I never buy courses, but this guy seems like a pretty good guy overall. So plus a lot, again, like I was saying, a lot of his stuff is like tutorials and stuff. Like a lot of these tend to be free anyways. But it's just okay, you can look now, by the way, if you were worried about being blinded. Like this right here. This is saving and loading games in Godot 4. If you're worried about being blinded, this page is a lot better than the other ones. Like this is, I believe this is like completely free. It definitely looks like it. Like Venture 2. So, okay, whatever. But there's just like this whole thing. Again, a lot of his stuff is free. But yeah. This guy is definitely a great resource when it comes to stuff like this. Like if you have like questions about things like this. Learning resource. Or like he even has a video right here.
One thing you need in every game is to save the player's progression.
Yeah, it's like that. It's like 14 minutes. I like this guy. Let's get made. Okay. The video was made with Godot 3. The guy below has been rewritten for Godot 4. So he keeps his shit up to date too, which I like. But like this guy is like the guy for Godot learning usually. Like he's like extremely active with like the community and stuff. As far as I've seen and stuff, so I think yeah, he has, this is it, the GD school. This is paid stuff. Good fucking lord. Not a chance in hell. But you know, overall I'd say it was pretty good like learning tools and stuff. Like get pretty good tutorials overall. But anyways, I'll probably fuck around with this some more, find more specific stuff that I'm trying to figure out or anything, or I'll just go down this course until I start hitting stuff I don't know, and we'll go from there. But anyways, I think that's it for me tonight, everybody. Again, sorry I didn't really get that far into state machines or at all into state machines. We'll actually do it. I'll work on it next time. It's just I keep getting sidetracked on stuff. I'm like, oh, this looks interesting. Oh, this was cool. Let's look at this. Let's watch this. Let's read this. My attention span's not great, so we'll get it figured out. We're gonna have to get that figured out. Like that's like something we need, like actively. So, anyways, until then, I'll see you guys all next time. Thank you all so much for watching once again. Good night, everybody. Bye-bye. 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 Bye.